given the limit of f of x as x approaches c equals to 8 over 7, and the limit of g sub x as x approaches c is equal to 6 over 7. Question number, or A for that one, now 1A. Find the limit, this is just making sure you know the rules here, as x approaches c of 4 times f of x. And one of the rules in our book says if you have a constant here, you can take the constant, move it to the front. I can take this 4 and move it all the way here. So if I do that, this becomes 4 times the, or c, not 4, 4 times the limit as x approaches c of f of x. Well, we know the answer to this. That was given to us in the problem. That was what? 8 over 7. That will be 4 times 8 over 7. The 4 is 4 over 1. When you multiply, what's 4 times 7? I mean 4 times 8. 32 over what? 7. Second part of the question. Where'd you go? Here we go. The second part, let's find the limit as x approaches c of f of x plus g sub x. And again, we have another rule that says if you have an addition, you can break it down to 2 separate pieces. Do we know the answer to each one? What's the answer to this? Isn't that 8 over 7? And what's the answer to the second one? 6 over 7. 8 plus 6 is what? Is that 14? 14 over 7, which is 2. The next one, of f of x times g sub x. Again, you can break it down to 2 separate problems. The first one, the limit of f of x as x approaches c times the limit of g sub x as x approaches c. 8 over 7 times 6 over 7. 8 times 6 is what? 48. 7 times 7 is 49. And the last one, f over g. Again, you can break it down to 2 separate ones. I don't have room to write them there. So we take the answer of f, which is what? 8 over 7, divided by the answer of g, which is what? 6 over 7. You simplify that, that's actually 8 over 6. If you multiply the top and the bottom by 7, the 7s will disappear. You got to simplify that, that's 4 over 3. So you're just knowing really what the rules are. If you're not sure about this one, the math, I'll just quickly here. 8 over 7 divided by what? 6 over 7, right? It says 8 over 7, when you look at it, divided by 6 over 7. How do we do division? We change it to what? Multiplication. It becomes 7 over 6. And what happens to the 7s? They cancel out, and you end up with 8 over 6, which is 4 over 3. That's one way of doing it. Another way of doing it, this big fraction, you see, you know what? If I multiply the top and the bottom by 7, it's not going to change the big fraction. It's a fraction. Whatever I do to the top, I got to do the same thing to the bottom. That's times 7, not 0.7. And these 7s will cancel each other out. You end up with what? 8 over 6. And you can simplify it 4 over 3. You don't like that? No problem. Third way. When you have 8 over 7 divided by 6 over 7, it's the outside over the inside. Always. 8 times 7, that's the outside. The inside is what? 6 times 7. The 7s will cancel. 8 over 6. Any way you want to. The answer is the same. You should never use that sheet of paper. I was trying to save paper for that person who yells at me. But you can see the back side now. I once shot that picture there, that paper there. Let's look at 15. We have f of x equals x over x squared minus 2x. And they give us the graph for it, actually. The graph was given, so I don't have to work hard for it. When x is 0, it has a hole in it. We have an asymptote at 2. There's a vertical line going up like this at 2. And the graph looks like this. That was given to us in the problem. And after that, it looks like this. Has a hole here and continues to go down like this. So that's what the picture looks like. This is the 2 here. This is question number 15. And the question, what's the limit of f of x as x approaches 2? Now I can block the entire picture here and just do that without having, I'll take my phone, cover that even. I don't want to see that. I can do that mathematically. Remember, as x, the question, what's the limit of f of x as x approaches 2? Is it 2? Yep. Well, if you look at that direct substitution, when x is 2, what are you going to have? 2 divided by what? 0, isn't it? And when you have 0 on the bottom, we say you have a problem. So we're not going to accept that answer. Can I clean that? What can we do? You can factor an x out of the bottom, right? When you factor the x, this x will cancel that x. So this becomes the limit as x approaches 2 of 1 over x minus 2. So when x is 2 now, what do you have? 1 over 0. Still a problem. Because you can't divide by 0. Now the question, okay, is there anything I can simplify? I can do it to 1 over x minus 2? Not really. I can't simplify it. So the only solution left for me if I don't have the graph is what? The table. Since they gave us the graph, I don't have to worry about that. Look at it. From the left side, where's the y value going toward? Negative infinity. From the right side, where's it going? Positive infinity. So what's the answer to this? The limit as x approaches 2? Its DNE does not exist. I didn't even have to do the math here. I just want to see if I can get the answer without doing the picture there. In this case, it didn't work out. For x approaches 0, I can use the math. You can see from the picture here, that goes to what? We'll see what the y value. I can't tell from the picture there. It's really deceiving. It looks like a half maybe. But we'll see. Negative 1/2, I mean. I'm going to do it mathematically. So that's equal the limit as x approaches 0. Direct substitution. Direct substitution, 0 over 0. Problem. We also said if you simplify, you end up with that. So let's try the simplified version. Because if you simplify that, that's what you have. Try direct substitution now. What are you going to have with direct substitution? 1 over 0 minus the 2, which is what? Negative 1/2. And if I looked at my picture closely, you probably see a negative 1/2 there. So DNE as x approaches the 2, negative 1/2 as x approaches 0. They even give you a little hint, right? A simpler function. Well, a simpler function is 1 over what? X minus 2. Right? The only difference between this function and that function, this actually has a value when x equals to 0. That does not have a value when x equals 0. So if you want to simplify this, you can say x over x squared minus 2x is equal to 1 over x minus 2, as long as what? X does not equal to 0 or 2. Because if x is 2, neither one is defined. And if x does not equal to 0 here, actually, if you want to make them equal to each other, just put the 0. Because neither one can be 2, so we know that. But when x is 0, this one has a value, this does not. If you say x cannot be 0 for this, that eliminates that little problem. But neither one has a value when x is 2, so I don't have to put that in. We know that. That was 15. Let me see, 17. This is straightforward. Find the limit as x approaches negative 1 of 2x squared minus 2x minus the 4 divided by x plus 1. Again, direct substitution is always your first step. If I do direct substitution, what do we have in the bottom? I don't care about the top, but in the bottom is going to be what? 0. I have no idea what the top is. Some number. Could be 0, could be something else, but I don't care. As long as the bottom is 0, you can't divide by 0. So let's simplify that. Maybe we can factor it. Well, to factor that, what is the first rule of factoring? What do you remember about factoring? The first rule is the greatest common factor, which is what? The largest thing they have in common. Look at the three things. What is the biggest thing they have in common? Isn't that a 2? That's the first thing. Am I done factoring? Probably not. Can I factor more? the x squared minus x minus 2. There's a good chance one of them is going to be plus 1. Could it be x minus 2x plus 1? And notice now these two will cancel each other. This will be the limit as x approaches negative 1 of 2 times x minus 2. So this question has two parts. One of them, write the simplified function to this. This is the simplified function of that one. Now, what's the value when x approaches negative 1? Try again direct substitution. That's 2 times negative 1 minus the 2. That's a negative 3. Is that a negative 6? So my answer for that will be a negative 6. Yes?
What if the numerator was 0 but the denominator was a different number?
That'll be a 0.
Would that be a problem?
Nope. Leon, as long as the bottom is not a 0, it's not a problem. So if you get a 0 on the top, 0 over anything is always a 0. That's an answer. But once you get 0 on the bottom, you can't divide that. Any other question on this? Okay, I got a few more. 23. Oh, maybe the special rules here. The limit as theta approaches 0 of cosine 5 theta tangent 3 theta over theta. Again, direct substitution is the best way. Let's try direct substitution. And I can see a problem already. I don't even have to do it. It's going to be cosine of 0. You have to look at your unit circle. Tangent 0 over 0. Again, doesn't really matter what the top numbers are. We got a 0 in the bottom. I don't want to go to the table. I'm not a fan of the table. A lot of work. The tangent. Isn't that sine over cosine? Right there. Tangent, rule number 3. Sine over cosine. So I should be able to write that. Cosine 5 theta. There's theta on the bottom. The tangent is sine 3 theta over what? Cosine 3 theta. Let me reshuffle that. Let me write that cosine 5 theta over cosine 3 theta times sine 3 theta over theta. Like this. Doesn't matter which one you write first. I put this over that and this over this. Now I can break it down using that property, break it down to the limit of the first, the limit of the second. Cosine of 5 theta over cosine 3 theta times the limit theta approaches 0 sine 3 theta over theta. 2 pieces. This actually I can find the answer to by direct substitution. If I do direct substitution, that's cosine of 0 over cosine of 0, right? Theta 0, 5 times 0 is 0, over cosine of 0. What's cosine 0 over cosine 0? Isn't that a 1? This is a problem. Notice that's 3 theta, this is theta. I need that to match this. Remember that on the board? We did that early? Still there, actually. So I need to multiply this one by 3 to match that one, and this one by 3. Top of this fraction by 3, the bottom by 3. And I'm going to take that 3 and put in the front. This will be 3 times the limit theta approaches 0 sine 3 theta over 3 theta. And I know the answer to this is 1. So what is 3 times 1? 3. What's 1 times 3? 3. So my final answer to that question is actually a 3. Good question. I like that one. I was making a test. I'll throw that on a test. Let's look at 24 and 25. Okay. Number 24, the limit x approaches pi over 2 of 3 cosine of x over cotangent x. You know we can take the 3 to the front, put it outside the limit. Less distraction. So that'll be 3 times the limit as x approaches pi over 2. And now let's see if I can simplify that. That's cosine of x. What's the cotangent? Isn't that cosine of x over what? Sine of x? Isn't that what a cotangent is? Do I have that on the board somewhere? Number 6. Cotangent theta is cosine theta over sine theta. Let's see if I can simplify this algebra here. That means what? Cosine theta divided by, that's what it tells me, right? Divided by cosine x over sine of x. The top one is over 1. We change division to what? Multiplications? And this becomes cosine of x over 1 times the sine of x over cosine of x. And what do you know? These two cancel each other out. And you end up with 3 times the limit as x approaches pi over 2 of sine of x. And now you try direct substitution for this. So it's 3 times sine pi over 2. And if you have your unit circle, sine pi over 2 is equal to what? 1. 3 times the 1, which is what? 3. So we just played with the algebra, try to simplify that. And when you simplify it, oh, that's equal to sine of x. All of this equal to sine of x. So the limit of this is the same as the limit of this. And number 25, the last one here. sine of 6t over 5t. Notice they don't match. This is 6t, this is 5t. You need to make this number matches that one. 6, right? How do you turn the 5 to 6? Can I multiply the bottom here by 6 over 5? Would that make it a 6 if I do that? Because the 5s will cancel. So if you multiply the bottom by 6 over 5, you better multiply the top by 6 over 5. Because your job is to make sure these numbers are the same. So that becomes the limit as t approaches 0 of 6 over 5. Now sine 6t over 6t. And the 6 over 5 will come right in the front. The limit as t approaches 0, sine 6t over 6t. We know the answer to this is what? 1. And that's 6 over 5.